Okay, so question asked, how do I do question 6 from exercise 2 in integral maths, section 2, the chain rule? So here's our question, an ice cube melting. So we go to question 6 there. Let's see how we can answer it. So to do this, I like to draw out a cube. Makes me feel comfortable drawing out my cube. I know where I'm at then. And it says it's all x. And it says that's what the volume is, so V equals x cubed. And then the question says, if I look through the question, it says that at time t hours, it has the form of the cube x centimeters and its volume is V cubed. At a certain instant, each edge measures 20 centimeters, that's important, and is decreasing at 0.2 centimeters per hour. At what rate is the volume decreasing? So let's just look at where it says it's decreasing at 0.2. So that's quite important. It's decreasing at 0.2 centimeters per hour. And that's a rate of change here. So I can rewrite that in algebraic terms. I've got my length here, which you call x, and my time here, which you call t. So I can write that as dx dt. And I know that's decreasing, so therefore it's minus 0.2. So I already know that. That's really important. Now the question asks, it says, at what rate is the volume decreasing? So what the question is asking is dv dt when x is 20. So I know I've got my dx dt, so I can put dx dt there, but I need to times dx dt by something, so that these two can cancel out and I end up with dv dt. So clearly I need dv on my numerator and dx on my denominator. So can I find an equation with v and x? Yes, here. So I can differentiate that. dv dx equals 3x squared. Brilliant. And I know the rate of change when x is 20. So what I do now is I go, right, well, that equals the x dt, which is minus 0.2, times dv dx, which is 3 lots of 20 squared, because it says when x is 20. And if I did that on my calculator, so I do minus 0.2 times 3 times bracket 20 squared. You probably can order this in your head very happily, but I get minus 240. So that is my rate of change when x is 20. So the volume is decreasing at a rate. Now you can either say, you could say it's increasing, but that would be odd. But you say it's decreasing at a rate of 240 centimeter cubes per hour. So decreasing at a rate of 240 centimeter cubes per hour. Hope that helps.